This is Trial Exam 2019. This is SP paper question number 8. This question is about sound waves. Sound is an example of a type of wave. State the name of this type of wave. There's only two types of waves that we look at. And this one is a longitudinal wave. You might want to go back and have a look at why that is. What's the difference between longitudinal and transverse if you're not sure. The speed of sound in liquids is greater than the speed of sound in gases. Describe the arrangement of particles in liquids and in gases. You may use diagrams to help your answer. So we should have liquids are arranged randomly, but there's no structure to them, but they do all touch each other. So you should make sure that there's, I'm starting to make it look like there is a pattern there, but there isn't for liquids. And then gases are just far apart. So we should say the particles are arranged randomly. You could say irregularly for that as well. And particles in a liquid are close together. Closer together. And we're only looking for 2 marks here, so what's the main differences between a liquid and a gas? Well, in a gas, the particles are a lot further apart. Remember, you want to stick to just talking about the arrangement. Don't try and shy into things like, oh, the particles in a gas are moving faster. Well, that's not anything to do with their arrangement. So then we're going to suggest why the speed of sound in liquids is greater than the speed of sound in gases. So first of all, how does sound travel? Sound travels as a vibration. So how are those vibrations traveling? Well, they travel when they hit a particle that's next to them. So they have to pass on the vibrations by colliding with the next particle. So because liquids are closer together, the particles in liquids are closer together, they pass along the vibrations more effectively. So liquids pass vibrations more easily because those particles are closer together. 2 marks, very easy. Now, a buzzer is an electrical device that produces a sound. The frequency of our sound is 1400 hertz. State the equation linking speed, frequency, and wavelength. So V equals F times lambda. That's going to be our 1 mark. The speed, sound travels at 340 meters per second. What is our wavelength? So then wavelength is V over lambda. So that's 340 meters per second divided by 1400 hertz. And then we get our wavelength to be 0.24 meters. And that's question number 8.